So let's take a look at number 6. We got 3 elements. We've got nitrogen, silicon, and phosphorus. If you look at the periodic table, these 3 elements are located like this, right? You have nitrogen, you have phosphorus, and you have silicon right here. Okay? So 2 things going on right here. So we have 2 sets of elements, one in period 2 and one in period 3, right? The first nitrogen is in period 2, and silicon and phosphorus are in period 3, while silicon is in group 14, and nitrogen and phosphorus are in group 15. So we say, hey, can you list them in order of increasing ionization energy? So increasing means you go from the smallest to the largest. So which one will have the easiest time to remove the first electron? The first one will be silicon. Because the more the energy levels, it's farther away, right? And do not forget what you learned about Coulomb's law. What about Coulomb's law? Is this, right? And the R, which is the distance, is being squared. So the impact by the distance is going to be doubled, okay, than any other things. So that's why anything in period 3 is going to have a smaller ionization than period 2 because you have one extra layer farther away from the nucleus. So the first one is silicon, because compare silicon and phosphorus. Phosphorus has a greater effective nuclear charge, therefore it has a stronger attraction, and therefore it's harder to remove the first electron. Because silicon has 14 protons, phosphorus got 15 protons. The effective nuclear charge for silicon is 4, while the effective nuclear charge for phosphorus is 5. And then the highest will be nitrogen, because it's closest to the nucleus. Okay? So when you're looking at these ranking problems, ranking questions, and you will for sure get these ranking questions, you've got to ask yourself, did you think clearly? Do you know which one comes first? Which one comes second? The priorities must be clear. Increasing atomic radius. That means you want to go from the smallest to the largest. Well, the smallest will be the one with the least amount of energy levels, and more to the right because of strongest or stronger nuclear charge. Nitrogen is the first one. And then between silicon and phosphorus, which one? It's smaller. Phosphorus, smaller, stronger attraction. Okay? And the last one is silicon. Now, this is something I would do, either mentally or physically. I would like to do this hand gesture to signify attraction. Understand that the more attraction it is when you go to the right-hand side. Okay? The noble gases are the smallest elements of each period. Okay? Because why? Make sure you know the why. You cannot really memorize this. You have to know the why. Once you appreciate the why, it becomes natural. Okay? It clicks. Everything is intuitive. Okay? Good? For phosphorus and then silicon? Yes, phosphorus has a greater nuclear charge, stronger attraction, more compact. Okay? Stronger magnets, if you will, to pull them together. From smallest, Yeah. So, and here's another thing. Make sure you tell yourself, what does it mean by increasing? From smallest to largest, okay? If you think like you might still forget, then just go ahead, scribble this down like small and large. Scribble down. Doesn't hurt you, okay? All right, number 7. So they're all isoelectronic. So bromine minus, selenium 2 minus, and then you have rubidium plus and strontium 2 plus. Okay. So from smallest to the largest, from smallest to the largest. So if so, they're isoelectronic. That means they all have the same electron count. They all have 36 electrons. Okay, if you do the count, they all have the same electron configuration of krypton. Okay, but now you say, hey, what about the protons? Well, protons, strontium would be 38, rubidium is 37, bromine is 35, and selenium is 34. So it's a very simple concept. You have the same number of electrons, and if you have more protons, stronger attraction. Therefore, smaller in size. So which one's the smallest? Strontium 2 plus. Most protons, strongest attraction among all 4. And then rubidium plus, and then bromine minus, and then selenium 2 minus. Isoelectronic series is just a very fancy way to say like they all have the same amount of electrons. These ions, they're all stable. They all have 36 total electrons. So that means now you can compare them on the same basis, that they have the same number of electrons. You may now go forth and compare the number of protons. Now understand the impact of protons. Cannot be possible. If they have the same number of protons, same element. Yeah. If they have the same electron and the same proton, that's the same element, same ion. Very good question. So if they want to give you something like, oh, some of them they have same number of electrons and others don't, I'm not saying it's not possible, then they would not say isoelectronic series. And what would happen, like I could also introduce something like F minus. Okay, how about I put an F minus right here? Then you know, well, F minus will be the smallest because it has only 2 energy levels. While others, they have 4 energy levels. So F minus has to be the smallest. No, the bigger it is. The more jackets you put on, the bulkier you will be. Okay? So is it possible? Yes, it's very possible. But if they ever give you something not isoelectronic, it must be obvious that you can tell where to put that ion on this comparison chart.